Good day, everyone. I am Pfizer Shell Amlata, and I am here to discuss the topic Basic Relations and Pictorial Representation. So, what is relation? Relation in mathematics defines a connection between elements of two sets. It essentially describes how elements from one set are associated with elements from another set. And a relation has its key components and terminology. First, ordered pair. Ordered pair is a relation represented by a set of ordered pairs. Each ordered pair, A and B, indicates that element A from the first set is related to element B from the second set. Second, domain. The domain of a relation is the set of all elements or the set of all first elements in ordered pairs. Third, range. The range of a relation is the set of all second elements in the ordered pairs. Fourth, codomain. The codomain of a relation is the entire set from which the second elements are drawn. The range is always a subset of a codomain. Let's say set A, which contains the element 1, 2, 3, and set B, which contains the element AB. We define a relation R as follows. R, which contains the element ordered pair 1A, 2B, and 3A. So, atong i-identify ang iyahang Cartesian product, which is A cross B, which is its function 1A, 1B, 2A, 2B, 3A, and 3B. And its relation 1A, 2B, and 3A. And the domain is the first element in the ordered pair, which is the 1, 2, and 3. And the range of R, which is the second element of ordered pair, AB. So now, let's define if this relation is true. 1 is R related to A. It is true because ordered pair 1A is an element of R. 2 is R related to B. It is also true because ordered pair 2B is an element of R. 1 is R related to B. It is false because ordered pair 1B is not an element of R. So, makita man siguro ninyo sa example na ang ordered pair ni 1 is si A and ang ordered pair ni 2 is si B. So now, let's proceed to universal empty equality relations. So let me define first the universal relation. For any set A, the universal relation is defined as A cross A. This means it's the set of all possible ordered pairs, where A and B are elements of A, and every element in A is related to every other element in A, including itself. So here is the example. If A contains the element 1 and 2, then the universal relation A cross A, which contains the ordered pair element 1, 1, 1, 2, 2, 1, and 2, 2. Empty relation. For any set A, the empty relation is the empty set. It contains no ordered pairs. No element in A is related to any other element in A. Example, if A contains the element 1 and 2, then the empty relation is the null set. Lastly, the equality relation. The equality relation in a set A is the set of all ordered pairs, where A is an element of A. Each element is only related to itself. This is also called the identity relation because it represents the identity mapping of A to itself. So here is the example. If A contains the element 1, 2, 3, the equality relation is 1, 1, 2, 2, and 3, 3. Inverse relation. An inverse relation is essentially a reversal of a given relation. If you have a relation R that connects elements from set A to set B, the inverse relation denoted as R raised to the power of negative 1 or the R inverse connects elements from set B to set A. Specifically, original relation R, if ordered pair A and B is an element of R, meaning A is related to B in R. Then, the inverse relation, denoted as ordered pair BA, which is an element of inverse relation, meaning B is related to A in inverse relation. Let R be a relation from set A to set B. The inverse relation R, denoted as R minus 1 or R raised to the power of negative 1. It is a relation from B to A. It is formed by reversing the order of the elements in each ordered pair of R. Formally, R minus 1 or R inverse is equal to ordered pair element BA such that AB is an element of R. So here is the example. If R contains the element 1y, 1z, and 3y, then the R inverse or the relation inverse is equals to y1, z1, and y3. Notice how each ordered pair A and B in R becomes BA in inverse relation. So now let's proceed to representation of relation in finite sets. Suppose A and B are finite sets. The following are two ways of picturing a relation R from A to B. So the first way of picturing a relation is called matrix. But before we perform this, we need first to find the relation of A and B, where A contains the element 1, 2, 3, and set B contains the element x, y, z. So R contains the ordered pair element 1y, 1z, and 3y. Since we already had its relation, now we will picture this out. So form a rectangular array whose rows are labeled by the elements of A and B. And put a 1 or 0 in each position of the array according to its ordered pair, or an element where it is related or not. The second way of picturing a relation is called arrow diagram. So the same process, we need to find its relation and then picture out. So in this example, we need to write down the elements of A and the elements of B in two disjoint discs. And then draw an arrow from A is an element of A to B, an element of B, wherever A is related to B. We also have directed graph where we can also picture out its relation. So the same process, we need to find its relation and then graph it. So here, we will put numbers or the elements of each and then connect it. We will connect this based on the ordered pair in the relation. And that would be all. Thank you.